Hi, I have another problem from the internet. Um, a 50-foot wire runs from the roof of a building to the top of a 10-foot pole 14 feet across the street. How much taller would the pole have to be if the street were 16 feet wider and the wire remained the same length? Okay, so give this a shot. Work on it for 2 minutes and then come back. Okay, you're back, and now let's talk about this problem. Okay, obviously you want to try to draw a picture, but you're not going to have lined paper on the exam. But so here's the building. Here's 14 feet out. This is 10 feet up, and then you have the wire. Okay, 50-foot wire, and then 16 feet out from that, you have a pole of unknown height, and then again 50-foot wire. Okay. So now let's say you're doing this and you don't know what you're doing, and so you want to guess. So how would you guess? Well, if the pole is 10 feet, for a 14-foot wide street, the pole is 10 feet, then you can do a ratio. Then for 30 feet, it would be a height of x. And we can easily calculate x. X is 21.4 feet. And we want the difference in height between this pole and this pole, right? This difference. So 21.4 minus 10 gives us 11.4. And that puts us right in between B and C. B is the correct answer, but that got us close. So if you had to guess, you could, you could narrow it down to 2 using that method. That is a rough method. You see now there's a problem, because if you take this wire and you hang it straight down, it's not going to come to the ground. It's going to be slightly off. So theoretically, this should not be a 10. It should be less than 10. So, a few feet less than 10. I don't know how much, but a few feet. So because this is a little bit too big, your estimate is going to be big. Okay, so that the correct estimate is most likely B. And we already know the answer is B, but I'm just trying to give you a logical reason why we would go to B, because I use 10. That overestimates the height of this using this estimate method. Okay, let's say we want to do it the right way. They've given you the hypotenuse is 50 and the base is 14. Okay, and then they've give you another hypotenuse and base. So basically 2 right triangles. And so if you take the difference in height, okay, this height minus this height, if you take the difference in the height, then that will give you the difference in the pole height. Okay, so Pythagorean theorem, right? So here it's hypotenuse squared is equal to the other side squared, 14 squared plus our missing side squared, and the same for here, 50 squared equals 30 squared, and this squared, which I've written out here. And then you just move these to the other side and change the sign, which I've done here, take the square root, and you get H1 here is 48 and H2 is 40. And you subtract them and you get 8. And that's answer B. Now I wanted to point out, so when you get this kind of a problem and you don't know what to do, one way is, well, you see there's some triangles here, and they've given you 2 sides of the triangle. Maybe you should calculate the third side for both triangles and see if you can make that work somehow. So just kind of blindly like, oh, I don't know what to do. Let me just calculate the third side. Can I do anything with this? And the answer is, well, you probably can. So that's kind of how you need to start thinking about these problems when you're confused. Otherwise, you're going to have to try to estimate, but that might be hard. You might not figure that out in time as to how to estimate it. So hopefully that was helpful, and that's the end of the problem. Thanks. Bye.